All right, what's up? Admin of Code 2024, day 9. So sorry for uploading this kind of late. The part 2 of this problem for today was sort of kicking my butt here. But the problem that we have today is pretty interesting. We're doing sort of a defragmenting kind of problem where we have a disk map. So this is our input. The disk map, it's just a single line. And it's a format, it's a dense format to represent the layout of files and free space on the disk. So pretty much what's happening here is that this is a file, this is free space. Well, it's a file of this size, and then a space of this size, 3, a file of this size, and so on and so on. It just sort of alternates. And then from this example, expressed like that, this would turn into this. And each file is given a file ID. So the file ID is starting from 0 of, this one. It's just saying that there's two spaces of 2 blocks of data there. And since it's our first one, we're going to have the file ID of 0. So 2 blocks of file 0. And then 3 empty spaces, just like that. And then 3 blocks of our next file. And the next file ID would be 111. And so this just turns into that. Okay, so that's the first part of the problem. And the next part of the problem is actually, now we're just going to start sort of defragmenting things and sort of closing the gap of all the empty spaces with the data that we can. So for example, we start off like this, but we see that there's an empty space here and some files way over here. So we're going to bring him over there. And it's the same thing. We're just going to do this one by one. Move this guy to here, move this guy to there, and just keep doing that until we squeeze everything into one block like this. And the final step for this part 1, this one actually confused me for a while, was that we're going to calculate a sort of a file system checksum. Basically, we're going to go through each of these and then multiply its position by its ID number. So this would be 0 times 0, and this would be 1 times 0, and then 2 times 9, and then 3 times 9, and then 4 times 8. And we're going to get each of those products for each position. And the total sum of that is going to be our final answer of 1928. So we can go over here to take a look at my code for how we did this. So starting off here, this function, oops, I don't want to do that. This function does, so since it alternates between file space with this disk map, we're just going to go through each one. I just did a basic sort of like even odd kind of check as we iterate through that array. And if it's even, then we're going to add to our array. I've called it the block array. That number, so this would be the amount of space, or the amount of, or I guess in this case, the amount of file data times an array solely of the file ID. And the file ID is just like a counter variable that we just increment each time we come across a new file. Then otherwise, I chose -1 just to represent the empty space. That wasn't really necessary, but that's what I did. So the same thing, but instead of a file ID, it can be -1. I just saw that none of the input here is ever negative. So yeah, our block array is now this part. Okay. And so then I just do a sort of like 2-pointer kind of solution here by starting at the ends. So if we start I at the very left side, J on the very right side, while they're less than each other, while I don't cross paths, if what we're looking at the left side is an empty space, have to look looking at the right side as a file, we're just going to swap them, move the left side over by 1, and then move right side to the left by 1. This is what this basically means. And then if the data block that we're looking at is not empty and it's actually a file, and this is also a file, then that's has to wait for us to move it. But this, we're going to move on to the next empty space by incrementing this by 1. And if we're looking on the right side at an empty space, we're not going to want to touch that. We're looking for the next space that's a file, so we're going to decrement this by 1. And yeah, that actually works pretty good. And so the next part is just calculating the checksum, which is also pretty simple. We start off at 0. We go through this block array. Now that it's been sorted in the way that it needs to be sorted, if it's not empty space, we're just going to add to it the position times the data there, the file there, the file ID, and we get the answer. And so let's see. Yep. So we get the correct answer right there, 1928. Okay. Part 2 was another story. Part 2, I was pretty busy yesterday, and like I struggled a lot with it. It was definitely a lot more challenging. One of the big things that I didn't take into consideration was that the file IDs could be greater than 9, right? If you have a file ID of 10. So let me just open up what I did for part 2 here. So let me explain it. So it's basically the same thing where we have to produce this kind of array of data here. But now when we're going to move the things into the free space, we want the data of the files to stick together and not just move them one by one into the empty spaces. So this is a file here, this 9. We're going to move it to the next empty space from the left. So we're going to take this, and since this space is an appropriate size for it, it's greater than it or equal to it, we're just going to slap it right there. And in the next case for this file here of these 4 blocks of 8, if you look, there's actually not any space for it to fit in. So we're not going to do anything with it, and we're just going to move on to the next file of the 3 blocks of 7. And so looking from the left to right, so this wouldn't fit, but this one, since it's the same size, we can just smack it right there too. So that's the general process of how we're doing this. It sounds easy explaining it like that, but it was pretty tricky. My solution for part 2 is definitely much more involved. Let me zoom in a little bit there to make it a bit more legible for you guys. So let's see. Do just a test input. So I made a whole bunch of like just functions here just to make my life easier. So the big thing is this function that I've called defrag. So what I'm going to do is I'm going to get a list of the files to move, and this function get files. I reverse it because I want to start from the right, and then for every file that I want to move, I'm going to update this. This is going to be our disk data. I'm going to update the disk data, move file to free space, this function that I wrote myself, to that disk with the file. And so this is sort of the main function. And then now everything is just sort of explaining what do these 2 functions here, move file to free space and get files. So I'll start with get files because that's a lot easier. So it's just basically, we have a array here of files for the data in the array. If it's a file, the way I've sort of, for my schema here, if a file, to determine if a piece of data that we're looking at is a file, let's see, where is this file? So we look at the data, and if that first, we were passing an array, and if that first element of the array is just this empty space symbol, then it's not a file. Otherwise, it's true. My schema for this is pretty different. So let me show you how I've done it. That's just not really. Okay, so I've now done it this way where the blocks of data are represented as arrays like this. And that made things a lot easier, especially when things are, they can have a file ID greater than 9. Because if this is all just a string, kind of like this, it's like, you know, would that be like a file of just, like if the file would look like this, you know, is this 4 tens or just like a 1 file, then a 0 file, a 1 file, then a 0 file? You get what I'm saying? So yeah, that's the scheme that I've been working with now. Okay, so the defrag function, or was I? Oh yeah, the is file. It just tells you if it's an empty space or if it's a file. Get files. Okay, yeah. So yeah, for the data in that disk array, if it's a file, then we're gonna append that to our files array and return that. So pretty simple. And then for files and files, so that's our files to move. And then for files to move, we're gonna do move file to free space. So move file to free space, what we're doing is we want to get all the spaces that are empty. And I made a function for that, get free space, and we're going to pass in that array. And then also we're going to need the index of that file because we want to get the space that are before that file that we're looking at. So let's see, where's get free space? So this one's spaces. So for I in range len of data, so we're just going to go through each of the blocks of data in the disk array. If this is a empty space, this could have been like if is not file, right? And I is less than file. File here is just like is actually just a index of that file they were looking at in the context before. So basically, this is just getting the spaces that are spaces and that there exist before that point in the block data in the disk data. So we're going to return those empty spaces. Okay, so we're going to go through each of those empty spaces, and then if move file. So now move file, this is the real sort of meaty bit here. This is definitely one of the more challenging aspects here. So we have an array for new data and the remaining space, and we're going to look at if the size difference is appropriate. So pretty much, if there's enough space for the file to fit, then we can do all this stuff, but otherwise we'll return false. So sometimes, you know, it'll return true if the moving succeeded, and it will return false if it wasn't possible. So all we're doing here is that new data is just a copy of the file, and then remaining space is just how much space is left over, and we're gonna keep that space in a different array. We're gonna get the index of the position of that empty space that we're considering, and the position of the old data that we're going to be moving. So what this here is doing is it's just overwriting where that file used to be with the dots, meaning it'll just be empty space. And then here we're going to delete from the disk the that space, that empty space. We're just going to delete that block there. And then if there was still remaining space left over after all this, we're going to insert that function, that array of remaining space into that position, and then also insert the new data, or the file, into that space, and return true. So that'll work. And yeah, so this is the first time doing advent code where I actually had to sort of rewrite everything, because usually for part 2s I can keep a lot of the same code that I did in part 1, but I had to really change how I approach this, and so it was pretty frustrating at first, but I also thought it was really cool kind of problem to work on. It reminded me of like classes I did in university for like operating systems and stuff like that, and I always thought that was like really interesting and cool. That's like a part of CS that I find fascinating. Yeah, so I like doing this problem overall, despite my struggles, and even though I'm uploading this video late. But yeah, thanks for watching. If you have any tips or advice for me, please let me know. Or if you think you have any criticism that you'd like to share, please post in the comments. I'm on the Advent of Code Discord, and you can reach out to me there. It's my first year doing this kind of problem, Advent of Code. I'm really enjoying it. And yeah, thank you for watching.